So let's look at some of the homeworks from 4.2. I'm going to do these three that I assigned as special problems. So let's remember, so we have, let's okay, number 8. So we have here three vectors. U is 2, 1, 4. V is 1, minus 1, 3. And W is 3, 2, 5. Okay, let me see that I don't copy it wrong. Okay, so, and the question now is, given certain vectors, show that they are a linear combination of these vectors, or put differently, that they're in the span of these vectors. And okay, so we have to trust that the problem is posed correctly and that they are actually in the span. Okay, but as I said, we will talk more about these spans later on in more generality. How does it work? Well, we write these actually, instead of writing them as rows, I'm going to actually consider them as columns. Like this is this column, this would be this 1, minus 1, 3, and this would be 3, 2, 5. And what is now linear combination of that would be x, I'm going to use x, y, and z, that's easier to write, 2, 1, 4, plus y times 1, minus 1, 3, plus z times 3, 2, 5. So that's how, this is a 2 here, and this is a z. Okay, so this is how a linear combination of these three vectors would look like if you write it in column. And so the question now is, find x, y, and z such that in this particular case, what was it? I said a b, and b was 6, 11, 6. 6, 11, 6. So it amounts to solving a system of equations, which, if you think about it, it just, you can write it out in a system of equation, but it's kind of useless work, because what is the coefficient matrix? So the matrix of the system is exactly now these columns, 2, 1, 4, 1, minus 1, 3, 3, 2, 5. So these are the three, these three vectors here, right? And the question now is 6, 11, 6 in the span? In other words, is the system solvable? And the way that we do this is by putting this into an augmented column and then row reduce and see where we get. Okay. We have a pivot. I have a 1 here. It's not in the right place, so the first thing I'm doing is just move it. I prefer to work this way, right? Moving is not a big deal. It's a little bit of writing, but that's okay. So I have 1, minus 1, 2, and 11, 2, 1, 3, 6, and 4, 3, 5, 6. Right. Okay. I have now my 1 and the two operations to get a 0 here and here. So what are they? Replace row 2 by row 2 minus 2 times row 1. Replace row 5 by row 4 minus, row 3 by 4 times row 1. Okay, so we get minus 1, 2, 11. So this is times negative 2, and then add it up there, so we get a 0 there. Minus 2 minus 2 plus 1 is 3. Minus 4 plus 3 is minus 1. Minus 22 plus 6 is minus 16. And now do the same here, but now with minus 4 go there, so 0. 4 plus 3 is 7. Minus 8 plus 5 is minus 3. And then minus 44 plus 6 is 44 is minus 38. Sorry. Yeah. Okay. Right. So our first pivot. Unfortunately, this is not such a nice problem. I apologize. The textbook sometimes have this bit uglier thing. So we don't have a pivot now right anymore. So we can do what we can. We have no 1 anymore in the second column, right? So this is supposed to be a 1, but we don't have it. You can divide by 3 here and make it a 1, and that introduces fractions. And that is perhaps the most straightforward way, but it is fractions. So let me give you another option that you have is you can try to make a 1 using these two numbers. Find a combination so that these two are actually give 1. It's not always obvious how to do that, but in this case it's not so bad. See, if I would do, and here's my suggestion, is replace row 3. I'm going to twice, if I subtract this guy twice from 7, I get 1, right? And that's what I want. So I do row 3 minus 2 times row 2. Okay? It's a intermediate step if you want, because I'm not going to get my pivot yet. But at least I get a 1. So this is minus 2 times now. That gives me 1. Then 2 minus 3 is minus 1, and then 32 minus 38 is minus 6. Okay, that made the numbers a little bit smaller. I have my 1, it's not on the right spot here. I have to swap with row 2. Right, I really have to follow this echelon. I have to make an echelon, right? So that 1 has to come at this position here. Okay. Okay, so swapping, that goes very quickly. I'm going to actually do that here. 1 minus 1, 2, 11. And then 0, 1, minus 1, negative 6, and 0, 3, negative 4, negative 16. Okay? And, right, so I have now my 1. What I need to make is this 0, and I do that by the row operation. So the row operation now that I'm doing here, I'll write it here, is row 3, replace that by subtracting 3 times row 2 from it. Okay? I repeat, so in case you still don't understand this fully, what it happens is always you have your pivot, and that means that this is in the row 2, and that's why I'm doing operations using row 2. Here my pivot was in row 1, and that's why I take a combination of row 1 and add or subtract it from the row that I want to work with. Okay, if I want to get this 2 in the 0, that's in our 2. For this 4, I did this operation, and so on. Okay, alright, so what I have is, I write it here, 1, negative 1, 2, and 11, 0, 1, minus 1, negative 6, nothing happens here. Now I'm multiplying this with this guy here, this guy with negative 3, and add it to this guy. So I get 0, 0, minus 3, that's plus 3, minus 1, that is 2, and then minus 6 times minus 8, no, plus 18 minus 16, that's also 2. Okay, we're almost there, right? Because luckily now we don't, although this is not a 1, it's easy to make a 1 by dividing this by 2. So I'm doing the operation row 3 divide by 2. Okay, and so that will give me a 1 here. I'm gonna be a little bit lazy and make the 1s already here. Okay. You have the video to watch, go back to see what it was. Okay, so now I have my 1 here. So this is now done, right? I did this. Okay, so I have now my 1, and this is the echelon form. So I'm now in echelon form, but I need reduced echelon form to find the actual solution. Right, be careful, right? So that is sometimes mistake people make, is to say, oh, this is the solution. No, not yet. We have to go into reduced echelon form. So for that, I need to make zeros here on top, the pivots. Okay, that's the second phase, if you want. Okay, so the operations that I need in this case, using this pivot, is I'm going to do row 2. No, let's do row 1 first. Row 1 I'm going to replace by subtracting twice row 3 from it. Again, because I'm using a pivot in the third row, that's why I'm doing an operation here with row 3. And I'm doing it on row 1. Okay, and now I'm the same for on row 2. I do row 2. What do I do? Well, I need this one with this minus 1, so I'm just adding them up. Okay, so what do we have? Okay, I'll do it here. So, right, which one am I doing first? This one, right? Yes, this one, sorry. This one, so I'm multiplying this with negative 2 and add it up. So negative 2 times this row here. So what do we get? Okay, nothing happens in the first two, then we get a 0 there. And what happens to the last column? We get a negative 2 plus 11, that is 9. And then now in the second row, what we did, we were just adding these two now. So we get a 0, a 1, a 0, and a negative 5. And then this is 0, 0, 1, 1. Okay, that takes care of this pivot now. Now, finally, we need a 0 on top of this guy. So this is easily done by row 1, adding row 2 to it. Right? Again, the pivot is in row 2, that's why I'm working with row 2. Okay, so we get 1, we're adding this, right? 0, 0, 4, 0, 1, 0, negative 5, 0, 0, 1, 1. So this is now our solution. That means if I use 4, negative 5, and 1, if we did this 4, this is 5, and this is negative 1. Did I copy it right? No, negative 5, sorry. This is negative 5, this is positive 1. We should get this. Let's just check for 1, the top one. 4 times 2 is 8, minus 5, plus 3. That's 6, right? And you see that the other combinations also work. 4 plus 5 plus 2, that's 11, and so on. Okay, so that's how we find these coefficients. And of course, if this system, if we would have gotten not a pivot in here, but a 0, but a 1 here, then we know the system was inconsistent, and that would have meant that the vector was not into the span. Okay, but in fact, it turns out that in this particular case, although the question doesn't mention that, but we will see this later, that the span of these three vectors here is everything. So every vector is in that span, and these are going to be important choices of vectors that span the whole space. Okay. Let's go to the next question. That was, what was that? 12C. So in 12C, what was the question? Now we have vectors, and the question now, is it in the span or not? Okay, now we don't know, so you have to check. And again, let's write the vectors. I'm going to write them really already as in columns, because that's really how we're going to work with them. These are now 4 vectors in 4-dimensional space. 3, minus 1, 5, 2. Sorry, what is that for a symbol? And V3 is minus 1, 0, 2, 1. Yep, okay. So, and now the question is 12C, is the vector 1, 1, 1 in there? That's the question, okay? So, it's 1, 1, 1, an element, let me write it like this, in the span of V1, V2, and V3. That was the question. What does this mean? This means that there is a linear combination of these three vectors that gives this. So that means that there's a system x V1 plus y V2 plus z times V3 is equal to my vector 1, 1, 1, 1. And again, this means, what as the previous case, what's the matrix of this system of equations is exactly the matrix given by these columns. That's why we have to write them as columns, not as rows, okay? Be very careful, these are now as columns. So, the matrix that I get is 2, 1, 0, 3, 3, minus 1, 5, 2, minus 1, 0, 2, 1. Okay, now, what do we do with this guy? Remember, we are trying to solve a system of equations. This is our augmented matrix, so it goes in a separate column. Okay, and then we roll the deuce, and then we'll see what we get. Okay. I'm going to use this pivot, but that requires me to first interchange row 1 and row 2. Sorry. So row 1 with row 2. Okay, I do this quickly. I get 1, minus 1, 0, 1. Then 2, 3, minus 1, 1, 0, 5, 2, 1, 3, 2, 1, 1. Okay. I have this pivot. I'm going to use this to get this guy and this guy 0. That is done by row 2 row 2 minus 2 times row 1, and row 4, replace that by row 4, minus 3 times row 1. So we get 1 minus 1, 0, 1. So now minus 2 here, 0, minus 6, that is negative 1, and that's minus 1. This one I don't do anything with. And then, wait, no, sorry, did I do this right? No, I made a mistake. Sorry, if I multiply this 2 plus 3, that's 5, not 6 here. Okay, be careful always, yeah, okay. And then now I'm multiplying with negative 3 and add it up here, so I get 0. Negative 3 times 1, 3 plus 2, that's also 5, and I get a 1 here. And what do we get here? Negative 3 plus 1 is negative 2. Okay, so that's my first pivot in my first column. The next column is the second column, but unfortunately no ones. And it's actually a bit bad here. I cannot do this trick that I did in the previous case to get a 1 there, because they're all multiples of 5. So whatever I do with them, it's always going to be a multiple of 5. So I have really no other choice here than divide by 5 by one of them. So let's just take the first one. Row 2, I mean. So I replace row 2 by 1/5 of row 2. Okay. Allow me to do this on my thing here again. So this will be that would be 1. This would be minus 1/5 and minus 1/5. Okay, I've done this row operation now, so it's no longer actually. Okay. This is now my pivot, and for that I'm going to make these guys 0 by the row operations. Row 3, replace that by row 3 minus 5 times row 2, and row 4 the same. Okay, so what we get? 1 minus 1, 0, 1, 0, 1, minus 1/5, minus 1/5, 0, 0. So we multiply this with negative 5 and add up. That's 0. Negative 5 times minus 1/5, that is negative is 1. And I add that to 2, that's 3. And here again, 1 plus 1 is 2. Okay. Yeah, by the way, before I divided by 5, I could have used that 5 that I used to have here to make these two guys 0 by just subtracting. That is another option that you had, but I chose this one. Okay. It eventually comes down all to the same thing. Remember, these row-reduced matrices are always uniquely determined. Okay. What do we have? Oh, I have to still do the next row. I forgot to do that one. 0, 0. Negative 5 times negative 1/5, that is 1, plus 1 is 2, and then that is here minus 1. Okay. Yeah. I have a feeling I made another mistake. Did I? No, I think I did it right. Yeah, I did it right. Okay, no, unfortunately, again, we don't have a 1 anymore in the next, so we have our 2 pivots, but the next one should be, this will be 1, so again, I'm going to divide by 3. Okay, I'm doing, so the row operation I'm going to do is row 3 divided by 1 by 3, so 1/3 of that. I'm going to again do this on my thing here, because otherwise it's too much writing. But be very careful when you do this. Of course, I have this nice iPad I can do this with. By all means, you can use Notability or something like that to write your solutions up to. Okay, make sure that the file too are not too big. Okay, all right. So here we go. We have now 1. So the row operation that I need to do to get a 0 in this pot is row 4. Replace that row 4 minus 2 times row 3. Okay, so I get 1, 1, minus 1, 0, 1, 0, 1, negative 1 fifth, negative 1 fifth, 0, 0, 1, 2 thirds, and 0, 0, 0. So I'm multiplying this with negative 2 and add it up. So we get negative 4 thirds minus 1. So negative 4 thirds minus 1, that is negative 7 thirds. Okay, so we have our 3 pivots. And so the next column is this column, and this is the pivot in the column. But if you have a pivot in the augmented column, this means no solution. Remember, why is this? Because this, what does this mean? This means 0 times x plus 0 times y plus 0 times z is equal to this number. That's not possible. So we have no solution. What does that mean? That means there is no linear combination that makes this happen. So this is not the case. So the answer is no. This is not in the span. Okay? That's how you prove that something is not in the span. And then that's the last question. Let me go a bit quicker on this one, 15a. The question is now, find an equation for the solution space. And the solution space is the matrix given minus 1, 1, 1. 3, minus 1, 0, and 2, negative 4, negative 5. Okay. All right, so what's the solution space of this thing? So what we need to do is just row reduce and find the general solution. Okay, so the system that we're solving is this. So what we really have is, perhaps it's good to remind ourselves of this, is that we have an extra augmented column here, which is all zeros, because this is now the 0 column. Okay, so I have a minus 1. Okay, so I have to multiply with negative 1. So row 1, replace that by negative row 1. Again, I'm going to do this here. So this is a plus, this is a minus, and this is a minus. And I'm not going to write my plus. Oops. Okay. Okay. So I have done this thing now. All right. So next thing to do is to get zeros here and here. And the row operations that do this is row 2 minus 3 times row 1, row 3 minus, minus 2 times row 1. Okay. So what I get is 1, negative 1, negative 1. Of course, in the back is always zeros. It's kind of useless to write it, but I'm just going to do it that you visually see what's going on. Okay, so times negative 3, and then add it up, that's 0. Negative 3 minus 1, that's 2. And then we get 3, that's 0 as we said. And then this is now 0, because now I multiply with negative 2 and add up. That is 2 minus 4 is negative 2. And that is 2 minus 5 is negative 3, 0. Okay. Unfortunately, again, don't have a 1, and I cannot make a 1 because the only two things that I can work with is, remember, this is a pivot, and so this row, the first row, is dealt with. I cannot use this row anymore, because otherwise, any time I use this row, I might screw up these zeros, which I don't want to do because I worked hard to get them. Okay, so with these two, but they are the same, so I cannot, they're always going to be even numbers, whatever I do with them. So the only resource that I have here is to divide by 2. Okay, so I'm going to do the operation. The textbook introduces some problems with fractions. Trust me, I'm going to try to avoid it as much as possible on quizzes. Okay, so the operation I do is divide row 2 by a half, which again I'm going to do here on the spot. So this becomes now 1, and this becomes 3 halves. Okay, I have this 1, and I have to make a 0. So what I do is, so this row operation is taken care of, and so I do now row 3 to add twice row 2 to it. Okay, that will give me 1, negative 1, negative 1, 0, 0, 1, 3 halves, 0, 0. So times negative 2 and adding, that's 0. Times negative 2, already cancels the 2. So negative 3 plus negative 3 is negative 6, and that's 0. Okay. I need to make this into 1, so the row operation again is row 3 divided by minus 1 over 6, which is now no problem because there's no zeros here, right? So I do get a 1 here, which again I'm going to do. So this is going to be just a 1, so after. And now you use this 1 to get the pivots that I want. So what we see here, we can already, the question was more, well, it also asks us to find the solution, but what you see is what we're going to get is a unique solution. And then it's kind of obvious what it's going to be, right? Because I know that if there's only one solution, it has to be the zero solution, because the zero solution is always a solution. So from this already I can tell that the only solution will be the zero solution. In other words, in this case, the solution set will consist of a single vector, the zero vector. If you don't believe me, do the continue making this into a reduced echelon form. But remember, what is the reduced echelon form going to look like? Well, the identity matrix. And what is this column going to look like? Well, nothing is happening to that column. It's always going to be 0. And then from that you see there's only one solution. X is 0, Y is 0, Z is 0. So the solution set is that. So that's an example where you can have a solution set that consists of one element. Okay. And if you do the other problems, you see some of them will be a plane, some of them will be lines. If you have questions about that, try yourself, but we'll do more examples of this in the next sections. All right.